Hi, this is Stephen Cherry for IEEE Spectrum's TechWise Conversations. The 134-year-old U.S. public phone network is dying. A third of all U.S. households are already cell phone only, and it's not just cellular that's killing them. More and more businesses and households are trading their traditional switched telephone service for Voice over Internet Protocol, or VoIP, services. That's led to a paradoxical situation where a huge number of phone calls start out as Internet packets and end as Internet packets, but have to be switched to and then from a voice circuit in between. What remains is to put the Internet Protocol in the middle of the network as well, and it's happening. In a 2009 filing with the Federal Communications Commission, AT&T, the largest phone provider in the world, indicated its support for, quote, the transition from the circuit-switched legacy network to broadband and IP-based communications. It went on to say that transition is underway already. With each passing day, more and more services are leaving the public switched telephone network and plain old telephone service as relics of a bygone era. And the company called on the government to give a date certain for the last plain old telephone call. In June, a Washington, D.C. advisory group, the Voice Communication Exchange Committee, formed and committed itself to a complete transition to the Internet Protocol by a date of its own choosing, June 15, 2018. The changeover will provide some enormous benefits to all of us, not least of which is high-definition voice service, similar to the transition from cathode ray television to HD TV. And it will provide some enormous benefits to the phone companies, including the surprising one of windfall profits from their legacy real estate holdings. My guest today is the founder of the Voice Communication Exchange Committee, Dan Berninger. He's an old Bell Labs hand from the 1990s, where he helped the old AT&T first come to grips with voice over IP. He's also had a hand in just about all of the early startups and deployments of VoIP, including Free World Dial-Up, Vocal Tech Communications, the Von Coalition, and Vonage. He joins us by, of course, telephone. Daniel, welcome to the podcast.
Thank you, Stephen. Thank you for having me and covering this topic.
Daniel, maybe just start by describing a modern telco, whether it's AT&T or China Telecom for that matter, and tell us where the Internet Protocol has and hasn't invaded and what still needs to be replaced.
Sure. It's interesting, actually, you should say modern telco. It's almost an oxymoron. Telcos, the service that they deliver hasn't changed in about 80 years. So you and I are communicating via a telephone here, and we could have done that in the 50s and for the most part in the 40s, and the only difference would be maybe a little bit different noise levels, etc. A modern telco, however, over the years, the phone companies certainly change what's under the hood, and so they do go through multiple technology evolutions, and the most recent one was to bring IP protocol into their networks. So most telephone companies these days move voice traffic and other types of traffic around their networks using Internet protocol. And so they sort of mix, in some cases, networks and parts of their network that would support data versus voice.
So how does the wireless world fit into all of this?
So you can think of wireless as just, a mile or a half a mile worth of air interface, and everything else about it ends up on wires and fiber and operates in a similar way that the wireline world works. The two networks, the wireline and the wireless networks, grew up separately, so they have, to some extent, separate infrastructures and separate switches, etc. But the vast majority of the wireless network is also wires and uses very similar technology. And one of the wins that we get in the transition to all IP networks is that everything will be a single network. So whether a fully unified network, whether they're moving video or a wireless call or a wireline call.
And I guess earlier air or wireless protocols would have had trouble with that, but the 4G networks that we're all moving to, the LTE, is basically IP to begin with, is that right?
Right, so LTE, which should come in the next 2 to 3 years and is out there to some extent for data already, is a native IP all the way. So it's built as a data platform, and then they overlay voice onto it. And previous to that, and in the 90s, of course, we had a voice infrastructure which we overlaid data. but of course there's much, much more data, whether voice or not, these days, and so the networks are optimized for data these days.
Now some phone companies, and not just in terms of wireless, but just some wired phone companies, have sort of tried this before, right? British Telecom had an ambitious program, for example, to phase out traditional telephony in favor of the Internet protocol. How did that work out?
So a number of carriers have moved along in terms of implementing Internet protocol in the middle of their networks. And British Telecom did and was able to sell a lot of their real estate as the bulk of the equipment shrunk. But what happens is they still end up exchanging traffic between each other in the same old circuit switch way. And so just about any carrier, I mean, even if you think of the world's largest carrier by revenue, AT&T, they're only about 2 or 3% of global telecom traffic. So ultimately, just about any carrier has to send any call that it gets off its own network. So the infrastructure between the networks is the key bottleneck at this point.
So how does that work? In the UK, for example, phone calls are all IP unless they're an international call. And then basically they all go to some central point, the phone calls, and interface with the traditional telecom world?
Right, because the regime for moving from one telephone company to another is a regulated, government-mandated regime ever since about 1913, after the Kingsbury Commitment. And so governments govern how one telephone network connects to another. And all those rules are sort of built in a lot of assumptions about old infrastructure, traditional circuit switching, TDM networks. And so it's very complicated and awkward to move off of that.
Now, you mentioned the real estate savings. I think you were the first to notice those enormous gains that the big telcos stand to make. In January, you wrote an article in which you used the word windfall. I guess the key to it is that IP routers take up a lot less space?
Well, it's a couple of things. When the regime for connecting networks was assembled in the last century, it was put together in a way that would make it difficult for new telephone companies to operate. It was what we call anti-competitive. So if you're an architect and you want to design something that would make it really hard for someone to get into the telephone business, what they did was connecting the networks was like connecting branches of a tree. So, you have thousands of branches. AT&T, for example, has something like 5,000 central offices. And in order to interconnect, you have to show up at each of those offices and connect in your trunks. That process of, having one tree talk to another through the limbs is extremely expensive. And in the places where the networks meet, they use essentially equipment that's 30, 40 years old, extremely cumbersome. I mean, some of this stuff still has discrete components in it. And essentially, when you go to Internet protocol, you can collapse, by 98% the number of places that you meet networks. And so a company like Comcast, which built its network in the 2000s, has 5 central offices versus AT&T's 5,000. So they, obtained a whole lot of savings relative to in their network infrastructure relative to AT&T. And so eventually AT&T can obtain those same benefits. As we speak, AT&T is one of the largest commercial real estate operators in the country.
The other big telco in the U.S. is Verizon. They had an ambitious capital expansion program to replace copper lines with optical fiber. And then suddenly a couple of years ago, they backed off, apparently because they were investing too much in the network and not enough in their shareholders, in effect. Even with the real estate windfall, as you call it, are the big telephone companies really going to make the huge investment that it's going to take to phase out the old network and make everything IP?
I don't want to speak for the telcos. I can give you sort of an analyst perspective, but essentially the transition we're going through as we transition to all IP networks reduces the operational expenses of what it takes to, move voice or any other type of media from point A to B. So the good news is that it gets a lot less expensive to do things. The second thing that happens is that you'll be able to offer new services, HD voice being a first example, but you'll also be able to integrate applications in voice a lot more completely and seamlessly. And so the carriers will essentially be able to increase their revenue per user. So if you have a situation where you have the possibility of increasing your revenue and decreasing your cost dramatically, it's pretty appealing for anyone to pursue. And then on top of that, there's a whole dynamic about the regulatory treatment of these networks.
I wanted to get to a high-definition voice. I remember back in, I don't know, it had to be 2000 or so, going to Avaya Labs. This was one of the Bell Labs spin-offs, and seeing and hearing HD voice in stereo, in fact. And yet so far, like our office phones are VoIP-based, and I've used Vonage and Skype. So far, IP has been kind of a giant step backward in audio quality instead of a step forward. What happened, and is it really going to get better?
Right. The reason we don't see HD out there today is because it is a really difficult transition to make, and that essentially when all the issues have been considered, there's no way to move to HD unless the entire industry moves to HD. And then once you have a challenge that requires an entire industry to do something, then of course you've got a very large challenge. Now the reason the whole industry has to move, because if you pick up a phone and you have 6 billion endpoints in theory that you could dial, so 6 billion numbers you could dial. If a particular carrier, implements HD, all of a sudden, great, I have, 3 or 4% of the potential numbers that I could dial could be HD. And it's a very difficult, education process, and, for the carrier to talk to its consumers, hey, 1 in every 33 calls you might be able to make an HD call. So the value proposition is very weak unless the whole industry moves.
Now, as I understand it, an ordinary landline phone call would use the equivalent, that's an analog call, but it would use the equivalent of about 64 kilobits per second. And HD would require about 4 times that, at 256 kilobits.
There's two different things. One is the frequency response that the user hears. So your ear, you and I are getting older, so we can't hear quite as well as our children, but generally, humans can hear from about 20 cycles up to about 20,000. And actually, since about in the mid-30s, telephone calls provide about 300 hertz up to 3,300 hertz. And that's obviously not even half of that range, the 20 to 20,000. It's not even a third. It's an important aspect of the range, but there's just a whole lot of the communication content that gets dropped on the floor. HD doubles that. So in HD, you go from about 80 to 7,000, and it captures a lot on the low end, a lot more of the presence and the feeling of who's talking. And on the high end, it captures a lot more of the high-frequency sounds that make it easier to tell the differences between words, the separation between the words. Now, there's another bandwidth issue, and that's what it takes to move that HD call from point A to point B. Now there, the news is good in the sense that the codecs don't require additional capacity. So a traditional wireline call would consume 64K to move from A to B. An HD call would require the same. And in the case of wireless, where they're even more stringent on use of bandwidth, a traditional wireless voice call might use something like 12.5 kilohertz, and a HD would be like 13.5. So it's very little difference. So it's not a problem of network capacity.
And one last question. How did you pick your date of June 15th, 2018?
We knew that we needed to pick a date certain to finish the project. Again, because if you hire an architect to build you a house, you don't sit there and say, well, just let me know when it's done. You have to talk to that architect and say, look, I have a move-in date at such and such a date, and we'll plan ourselves around that. So we knew we needed a date certain. It's the future, and so people say, well, is it 3 years? Is it 10 years? We picked 6 years as the duration of the project because historically 6 years is enough to get quite a bit done. Both world wars took less than 6 years. They completed the Panama Canal in 6 years. 6 years is enough to pretty much just about do anything that humans can think of doing. And so we picked 6 years. And as far as June 15th, 2018, it just so happened that we got started and got all of our companies talking to each other on June 15th, 2012. And so we just called that our, started the clock, and we were off to the races.
Well, I hope you do pull it off by your end date. It's kind of an amazing development. I think it's as far as I can see, much bigger than the transition to digital television, maybe by orders of magnitude.
Well, the reason it's bigger is that television is not baked into the economy the way communication is. So obviously they sold a lot of flat screens, and the Consumer Electronics Show did very well in the build-up to HDTV, and the industry itself, the revenue doubled in the years leading up to the transition date. But in the case of communications, telephone calls and just communications in general are baked into the economy. So we've seen great economic gains every time we get a big communication improvement from, whether we're talking about the Pony Express or telegrams or telephones or radios, et cetera. So this is a big paradigm shift. I would say it's kind of a once-per-century development.
Well, good luck with it, and thanks for joining us today.
No problem. Thanks for having me.
We've been speaking with Daniel Berninger of the Voice Communication Exchange Committee about shutting down the last phone switch by June 2018. For IEEE Spectrum's TechWise Conversations, I'm Stephen Sherry.
TechWise Conversations is sponsored by National Instruments.